my kind of territory. Spent an awful lot of time in these places.
So this is the type of workstation you have at Midway, the size of it.
Well, on the Midway it was a little bit different because what happened was each engine had its own engine room. In here we have two engines in this one space. Okay, Midway was a little bit more of a what they call a battleship design. Midway had more fire rooms. Midway also, you're right in front of a generator right there.
Yeah.
Hornet had 4 of those, the Midway has 8. Okay, so a lot more flexibility and a lot more protection built into it. The problem was that the Midway got designed during World War II, and the aircraft carriers were taking such a beating that basically they knew they had to go to a more robust design to be able to withstand the attacks that were going on.
Okay.
Okay, so everybody come on over this way, we're going to talk for a minute. That one? That's, how long ago? 10 years. Yeah, I started working here about 10 years ago. Okay, we have everybody down? Okay, very good. Welcome to the engine room. Where you are standing now, you're maybe about 20 feet below sea level. Okay, we're standing in front of one of the ship's 4 main engines, also known as Shirley. Sailor artwork. Shirley was a lady in the Philippines that a sailor really liked, and so the sailor came back on board and painted her name on the engine. And if Shirley is still around, and I hope she is, I don't know if she knows she has an engine named after her, but she would now be a senior citizen in the Philippines. Okay? What's happening down here is you have steam being produced in your boilers, coming to your high pressure turbine at 600 pounds and pressure in 850 degrees, coming through to your low pressure turbine in your crossover pipe. It's about 50 pounds pressure. The steam comes through here, expands through the turbine blading, you can see some of it right there, and then it goes down to a main condenser down below. Your main condenser has about 4,000 tubes running through it that are carrying seawater through, cooling the last of that steam and turning it into water or condensate. Okay? Your main condenser is going to be operating at about 29.5 inches of vacuum. So if you think about it, 600 pounds coming in, 50 pounds through the crossover, and a vacuum down below, all the energy from that steam is being imparted to these turbines. That turbine at full speed can be operating at about 5,700 RPM. This one, 4,000 and something RPM. They're linked via shaft into what's known as a reduction gear. Right there. You can't spin your propeller at 5,000 RPM, so the reduction gear reduces it down, gears it down, so the maximum speed on the shaft and propeller is going to be about 252 RPM. And if all 4 main engines are doing that, the ship will be doing, in World War II time, 33 knots, which is about 36 miles an hour. Okay? A little bit later on, when they modified the ship, they made it a bit heavier with flight deck modifications and things. The top speed went down to about 30 or 31 knots. Okay? Each engine capable of 37,500 horsepower, and you had 4 of these engines, so basically the ship's shaft horsepower was 150,000 horsepower. All right. So, questions at all? Okay. Once you're done in your turbines, you turn it back into water in your main condenser. Condensate pump picks it up. Air ejector is basically trying to remove the air out of the condenser and support the vacuum. Come back over to what's known as a deaerating feed tank. That is removing dissolved gases from the water that you have. Once you take that, you send it back to the fire room and they make steam again. So it's a continuous circular process of making the steam, using it to do work, and then turning it back into water, treating it, sending it back to the fire room. Okay? Alrighty, I'm going to take you over on that side, so I need to slip through here. This, by the way, is one of the ship's 4 generators for electricity. 1,250 kilowatt, if anyone here is interested in that. Okay. If you've been up on the bridge tour, you would have seen engine order telegraph. Right? Your lead helmsman is there, and when they want to make speed changes, what they do is they grab the handles on top of that, and they'll go ahead and they'll make the change. They'll go through multiple passes, because when they make a pass, what happens down here is ringing the bells. It's telling the throttleman, who's right here, there's a change. The throttleman's going to come over to the engine order telegraph, meet whatever the change is, acknowledge to the bridge, and come here to the throttle and be emitting more or less steam to meet whatever the change is. Okay? You can't make this change instantaneously. You have to keep your steam pressure consistent. If you come over here, for example, and they say slow down or stop, and you have a inexperienced throttleman and they do this, that steam has nowhere to go. The safety relief valve starts blowing open on top of that boiler. They shut the boiler down. This whole area goes dark. It'd be the responsibility of this poor person. Similarly, if they call down here and they say go fast, and this person doesn't think about it, what's going to happen is your steam pressure is going to drop. At 590 pounds, you lose your generator. Once again, everything goes dark. It's all on the shoulders of this poor 18-year-old that's right here. They could shut down this part of the ship. So hopefully they have enough training to be able to not do that, and enough supervision. By the way, the little desk or table where you are right there, that would be where the engineering officer of the watch would have been. And it would have taken a total crew of about 9 people underway to be able to operate this engine room, both engines. Okay, and there is a level below us too. There would have been a couple people down there in addition to the 7 that